Let's dive a little bit more deeper into the fact that you mentioned redundancy, right? So having parallel streams, parallel workflows actually, including failover, which is I think as important. Just having the redundancy is one, but the failover clashes, whatever reason, you still have an issue, which is very complicated, especially having two different workflows and also monitoring that, making sure you are able to switch at the right time at the right moment. It's extremely difficult. If you look at the workflow up to the CDN in general, how do you really ensure redundancy, failover, making sure you make the right decision of failover at the right time, and also don't have like switch back and forth, which I've also seen happening in different occasions. Can you highlight a little bit on how you do this on your end, Bob?
Yeah, so automatic failover is something that we shy away from. It is something that you can have, but as you said, you've got to be really careful about oscillation. So if you end up in a flapping situation where you're going backwards and forwards, you really don't want to do that. But if you build resilience into your design, for instance, you have highly resilient connections, you don't get that, because what we're talking about when we're talking about flipping sources, you want to avoid that. But up to that point, you've made sure that even if there is a failure, it's resilient in itself, so that it doesn't have an impact. But I come from a traditional broadcasting background. I used to work at the BBC and other places where we could have, even the analog era, we could have failures that you couldn't even see. Less than one frame of glitch, because things were timed and carefully synchronized. We don't really have that so much in the cloud world. We do a lot with timing to ensure that time is synchronous through things, but the head-end vendors have gone away as we've moved into the cloud from supporting synchronous head ends in diverse geographic locations. But actually that message is getting through now to some of the vendors that we would like synchronous head ends in the cloud, which then comes back to the other problem of how do you avoid coupling? So one failure in one location affecting the failure in another location, you want to avoid that. But if you're synchronizing, they're inherently coupled. But also, as you get that high geographic distance, how do you ensure that synchronization is real? How do you ensure that the definition of time is the same? And so making sure that your sources of time are reliable and the sources of time in the stream, and that you're measuring accurately what each thing is being, because the worst thing you could have is a stream switching between the two head ends and time jumping backwards and forwards. And yeah, so time and monitoring.
Michael, what's your take on this from your perspective? And you do this with multiple customers, a lot of customers. So you see different setups, different to monitor, and also the impact of that. What's your take on this?
I agree with Bob's statements. Automation and switching, especially CDN switching, is something maybe from the future, not too far future. Maybe if AI ML tools become smarter than humans and they can make the right decisions when it's really needed, then we'll see that more and more automated. But yes, redundancy it's like a spare tire in the car. You don't have a second car with you, right? So you can't afford to have fully redundant everything, but you have certain spare parts in your car. So if one tire goes flat, you just switch it to another tire, because tires are the ones that usually go flat, and other parts, well, they may break, but not that often. So you need to identify what parts are more sustainable to, or more prone to fail. So how do you ensure that everything stays in sync and switches seamlessly? Bob mentioned time synchronization. We're working with a number of partners on helping them enable better time synchronization technologies, especially in the cloud. On-prem inside the same data center, we have very well time synchronization mechanisms today, PTP, but PTP doesn't work in the cloud today. So we actually working on a project with another vendor to enable PTP distribution inside the cloud environments. And again, it brings me to the point. It's constant monitoring, knowing that something went wrong, something happened. It's looking for all the aspects of video quality, being in the content quality, so you can make a switch between the video sources if something happened. So the content quality itself, video, audio, metadata, it's the quality of streaming, quality of delivery of servers, name it whichever way you want. And of course, the quality of experience, right? You can collect that in real time with different tools and know what exact experience your customers are having at that point. So when monitoring tells you something and it alerts you immediately, it's like a sensor in the car, right? Everybody hates this engine yellow light in the car, but everybody needs that because if something fails, you want to know about it. There is a number of different technologies in place to help with seamless switching. And yes, you need to have them all the streams time synchronized and have the right timestamps in the streams. Things like EBP at some point, or even standards like SIMT 2064 for fingerprinting. We're using that standard to help identify the exact same video frames, regardless of the video format, resolution, bitrate, etc., across two different video streams, and that can help with the seamless switching as well.